Well, thank you for joining me on exercise 2A. I'm going to be looking at question 5, which says to use calculus techniques to determine the exact coordinates of any stationary points on the following curves. Use the second derivative test to determine whether the maximum, minimum, or horizontal inflection. So we've got our function. It's a cubic. And with a cubic, and it's a positive cubic, so it'll be going up at the end. We could have two stationary points, or we could have just one, or we could have no stationary points if it's actually got a point of oblique inflection point. Well, let's find the stationary points, and that's when the first derivative, dy dx, equals 0. So dy dx will be 3 times 1 is 3x, drop it down to a 2. 9 times 2 is 18, so minus 18, x to the power of 1. This is x to the power of 1, so 21 times 1 is 21, x to the power of 0. And of course this is x to the power of 0, so 60 times 0 is 0. So we've got this derivative, and we've got 3x squared minus 18x minus 21, because x to the power of 0 is equal to 1. I'll divide everything by 3. I'll divide everything, where has it gone? Let's try. We'll divide everything by 3. So we've got x squared minus 6x minus 7. Two numbers that multiply to give AC and add to give B. 1 times negative 7, they multiply to give negative 7. B is negative 6. So those two numbers would be negative 7 times positive 1, negative 7 plus positive 1. So the two numbers are negative 7 and positive 1. Therefore, x minus 7 would be a 0, or this other bracket, x plus 1 would be 0. Solving that, x is positive 7. Solving that, x is negative 1. So there's our two x values. To find the y values, you substitute x is negative 1 into the function. So we've got negative 1 cubed minus 9 times negative 1 squared minus 21 times negative 1 plus 60. So we've got negative 1, take away 9 because negative 1 squared is 1, plus 21, two negatives. So we've got 81, take away 10 is 71. So here's a stationary point, negative 1, a 71. When x is 7, bigger numbers, 7 cubed minus 9 times 7 squared minus 21 times 7 plus 60. So 7 times 7 is 49 times 7 is 343. Wow. 343. Is that right? Yep. And now 9 times 7 squared is 9 times 49. So that's like 9 times 50 is 450, but only 49, so 450, 443. Is that right? No, 441. 9 50s, but only 49 50s. 9 5s are 45. That should be 441. Okay. And 147 plus 60. So we've got 588 negatives. And we've got 403 positives. So we've got 8 minus 3 is 5, 8 minus 0 is 8, 5 take away 4 is 1, and it's a negative. So we have a turning point at 7, negative 185. Now we have to test them in the second derivative to see if it's positive or negative. So the second derivative will be, we go up to the first derivative, and the first derivative was this one. So that will be 3 2's are 6x, and 18 1's are minus 18, 21 0 is 0. So we substitute when x is negative 1, our second derivative will be, therefore, concave down. A concave down curve has a maximum value, maximum turning point at negative 171. Put x as positive 7 in the second derivative. d2y dx squared is 6 times 7, 42. Take away 18 is, what's that? 2, 24? 30, 42. And it's positive, therefore it's concave up, and a concave up curve will have a minimum. So it's a minimum at 7, negative 185. Wow. So we've got a minimum at 7, negative 185, a maximum at negative 171. I hope this has helped. Until next time, stay happy.